let's go for the one more application like this. High reactivity of allyl and benzyl alcohols. Towards Lucas reagent. We have in the previously we have studied what is Lucas reagent. The Lucas reagent is nothing but a concentrated HCl plus a mixture of anhydrous zinc chloride. So, no water containing zinc chloride and concentrated HCl mixture is known as Lucas reagent. Whenever this reagent is added to the alcohol, it becomes into the alkyl chloride, which is insoluble, therefore, you get turbidity. This concept we have applied on the different types of the alcohols. The tertiary alcohols gives this reaction fastly, therefore, immediate turbidity, 0 minutes turbidity comes. Secondary alcohol after 5 to 10 minutes, because it passes through its carbocation. So, the reaction is shown, it passes through carbocation. More the stable carbocation, faster will be the reaction. So, tertiary will takes place 0 minutes time will be 0 minutes. Secondary will 5 to 10 minutes. If time is we are measuring, the time will be 5 to 10 minutes. If primary is taken, the time will be infinite minutes or on heating. Now, you consider the allyl alcohol. What is allyl alcohol? Allyl alcohol is also basically is a primary alcohol. See, the carbon attached OH has got one alkyl group, therefore, it is called 1 degree alcohol, classified as a 1 degree. What is the expected reaction means? The time should be infinite minutes or only on heating reaction should take out. This is what the expectation. But allyl alcohol, the moment you add this Lucas reagent, immediately turbidity comes. 0 minutes, time is equals to 0 minutes. Within 0 minutes, turbidity is going to come. What is the turbidity? The turbidity is because of the allyl alcohol becomes into allyl chloride. This alkyl halides happens to be insoluble, therefore, turbidity is coming. So, within no time it becomes. Why? It is a primary. Why it is so means its intermediate is stabilized through the resonance, not through the tertiary. In the previous case, how it is tertiary gives fastly, tertiary is more stable. Tertiary carbocation is more stable through what feature means inductive effect we have studied. 3 plus I effects are there, therefore, it is more stable. Now, here it is not because of the inductive effect, because only one alkyl group, how can it show that greater inductive effect? It is showing the resonance in fact. So, the resonance is the real electrons movement when compared to inductive effect. Inductive effect only through bond, sigma bond, small electron density, but the resonance is real electron. So, the plus charge is totally shifted from that place. This carbon gets a neutral charge. So, therefore, stabilization of that carbocation for some extent is greater. So, therefore, the allyl alcohol, the moment you add Lucas reagent, immediately you will get turbidity, though it is primary. So, the question can be one type. Allyl alcohol gives fast turbidity, explain. Then you have to say it is a primary one, though it is a primary, has got a stabilization of the intermediate. Now, the question can also be allyl alcohol, it is a primary alcohol. He himself saying it is a primary alcohol. As per the general observation, primary alcohol should give delayed reaction, but he says this is also a primary, but it gives faster reaction. That means he is emphasizing the speciality of the allyl alcohol. He says it is primary. So, you cannot do that, the primary undergoes a faster reaction. So, he is saying it is a primary, even then it gives, that means you have to accept that the primary gives slow reaction. Then you have to give some another explanation apart from this primary. Now, it is the not because of primary, but it has a internal, that is after removal of this OH, the intermediate formed is allyl carbocation, it has a resonance eligibility. What is that? Pi charge eligibility is there, therefore the stabilization is taking place, fastly reacting. Even in the case of benzyl alcohol, benzyl is also benzene, not directly, through one CH2. This is called benzyl alcohol, benzyl plus OH, benzyl alcohol. The benzyl alcohol is also classified as 1 degree, no doubt, but its carbocation, that is benzyl carbocation, has got a resonance stability. So the plus charge, if it comes, the double bond in the ring can be polarized. So consequently this bond, that bond, and so on, 1 plus 3 resonance structures are coming. So therefore once again this gives a fast reaction, because intermediate is stabilized, so the reaction becomes very fast. This is also 1 degree. Specifically 1 degree should give very slow reaction, or on heating gives. But this benzyl is also happens to be a exceptional case. It is though 1 degree, but its intermediate is stabilized not through inductive effect, but through the another reason, that is resonance is stabilizing, therefore faster reaction. Like this, we have no doubt huge number of the applications are there, but much of the applications are mixed with the mesomeric. Even this also we can say this CH2 has a plus M group, therefore it is stabilizing. That means we are entering into the third phenomena called mesomeric effect. So let us stop here the applications of the resonance and take the another phenomena called mesomeric effect, wherein even this resonance and the mesomeric effect both together we can discuss the applications.